Topic: Mechanisms. Simple mechanisms. Levers, mechanical advantage. Simple quantitative treatment. No calculations using. Moments. Examine the relationship between load, effort, and their distances from the pivot. First-class levers. Characteristics. Fulcrum/pivot placed between effort and load. First-class levers may give a mechanical advantage or not, depending on pivot position. Case study: first-class levers with mechanical advantage. Ma 1. Ma equals 1, Ma 1. Second-class levers. Characteristics. Load is placed between effort and fulcrum. Give real examples. Demonstrate models of second-class levers, which always give a mechanical advantage. Third-class levers. Characteristics. Effort is placed between load and fulcrum. Give real examples. Demonstrate models of third-class levers, which never give a mechanical advantage. Practical investigation. Levers and linkages. Examine simple linked first-class levers, e.g. pair of scissors, pair of pliers, hedge trimming, shears. Examine simple linked second-class levers, e.g. office punch, nutcrackers. Examine simple linked third-class levers, e.g. most office staplers, pair of tweezers. Examine more complex linkages, e.g. linkages with more than one pivot. Mechanisms. A mechanism is a set of moving parts that work together to make our work easier. Machines are made up of different mechanisms. A bicycle is an example of a machine made up of different simple mechanisms. In Term 1, we will be learning about a mechanism called a lever. What is a lever? A lever is a simple mechanism that helps us to pull, push, or lift objects. It consists of a rigid bar that turns around a fixed point called a fulcrum or pivot. In the pictures below, Tom tries to lift one side of a block of concrete with a lever. The pictures show 3 different ways in which he can try to do so. 1. Which way do you think will work best, and why do you think so? 2. Describe what is different about the lever in each of these cases. Action research. Your teacher will demonstrate how a lever works. You need 3 things for this activity. A stick of about 30 centimeters long that can be used as a lever, a brick or a stone about the size of a brick, and something on which the lever can be supported. Now do the following. Use the stick as a lever to lift one side of the brick. Take note of the following. The point where the stick is supported by the brick or stone is called the fulcrum. The fulcrum can also be called the pivot point at which the lever is supported. The downward push made by your hand on the lever is called the input force or effort. The weight of the brick that keeps the other end of the lever down is called the load. When does the lever help you most? Underline the correct answer. It is when the fulcrum is close to /bar from the brick. When something is too heavy to lift by hand, you can use a lever to help you lift it. If you want to lift a heavy object, you should use a long lever and the fulcrum should be close to the object that you want to lift. If you give a soft or weak downwards push on the one side of the lever, there will be a strong upwards push on the object on the other side of the lever. Scientists and technologists use the phrase mechanical advantage, MA, to describe this. Advantage means that the lever makes it easier for you to lift the object. Figures A and B show that the lever gives you a greater mechanical advantage, MA, when the fulcrum is closer to the brick. Mechanical advantage, engineers say. In Figure A, the mechanical advantage is greater than 1. We get the task done more easily. The lever therefore offers us good mechanical advantage. Ma 1. In Figure B, the mechanical advantage is less than 1. There is no benefit from using this lever. It will not be easy to lift the brick. Ma 1. If the fulcrum was in the middle of the lever, it would provide no mechanical advantage. Engineers would indicated as follows. MA equals 1. We use levers because they may give us a mechanical advantage, MA. That means that, by make use of a lever, we can increase the force available to do useful work. It makes it easier for us to complete a task. In all levers, a force called an effort is applied to one end of a lever to lift a load. The above lever is an example of a first-class lever. Let's have a look at the 3 types of levers. Types of levers. There are 3 classes of levers and each has a fulcrum, load, and effort arranged in a different way. First-class levers. The fulcrum or pivot is between the effort and the load. Examples. Second-class levers. When the load is between the effort and the fulcrum. Example. Third-class levers. When the effort is between the fulcrum and the load. Example. Activity 1. Learners use their pencils to demonstrate the different levers. They complete the questions and line drawings. Activity 2. Informal assessment. Question 1. Lever A, Class 1. The fulcrum is between the load and effort. Lever B, Class 3. The effort is between the fulcrum and load. Lever C, Class 2. The load is between the fulcrum and the effort. Question 2. Lever B, Lever C. Question 3. You must ensure that you have a long lever by moving the fulcrum as close as possible to the load. Activity 1. Lift your finger in 3 different ways. Put your pencil on the desk in front of you. 1. Press the pencil down in the middle with your right index finger. Now try to lift your index finger by lifting the pencil at its point with your left hand, as shown below. When you do this, the pencil acts as a lever. A. What class lever are you demonstrating here? B. The line diagram below demonstrates the lever you created with your pencil. Indicate the following. On the drawing, load L, effort E, fulcrum F. 2. Press the pencil down at the point with your right index finger and try to lift your finger by lifting the pencil in the middle with your left hand, as shown below. A. What class of lever are you demonstrating here? B. Complete the line diagram below for the above lever by indicating the arrows and labeling the load. Effort, fulcrum. 3. Use your eraser as a fulcrum. Press the pencil down at the point with your one hand and try to lift your finger on the other side. The fulcrum must be in the middle. A. What class of lever are you demonstrating here? B. Draw a line diagram for the above lever. Indicate the arrows and label the load, effort, fulcrum. Levers and linkages. Levers can be used on their own or in pairs to help us to make work easier. Many tools, like scissors, pliers, and staplers make use of levers that are joined in pairs. These types of levers are called linkages. Definition: a linkage is a lever that is made up out of 2 or more levers. Linked first-class levers. A pair of scissors is an example of a linked first-class lever. It is made up of 2 levers that are linked. The effort is the handle. The load is when the paper is cut. The fulcrum is between the load and the effort. Other examples: a pair of pliers and hedge trimming shears. Linked second-class levers. A nutcracker and an office punch are examples of linked second-class levers. Linked third-class levers. Most office staplers and tweezers are examples of third-class levers. More complex linkages. A complex linkage is made up of a number of levers, more than 2, that are joined together. These linkages are connected together by different pivots. Some of these pivots are fixed pivots and some are moving pivots. Examples of complex linkages. Activity 2. Look at levers below and answer the questions. 1. Classify the following levers as first, second, or third-class levers and explain your classification. 2. Draw a line diagram for each of the above levers indicating the effort, load, and fulcrum. The first one is done for you.